So here in DFA, we are going to use some two important rules. The two important rules are, the first one, there are no moves on input empty string. So we are not going to use that empty string representation at all. This is going to be the first rule that we are going to use in deterministic finite automaton. So this is going to be the first difference actually between NFA and DFA. So in NFA we used to use the empty string representation using this belong to symbol, but here in DFA we are not going to use those empty string representation. That's going to be the first difference. And the second thing, for each state S and an input symbol A, there is exactly one edge out of S labeled A. So this is going to be the second important rule. So from each and every state we are going to do some transition. So we used to have those outer directed edges. We used to call that arrow as an outer directed edges because it is flowing towards outward. So we used to call that particular arrow as an outer directed edges, and sometimes we used to call the same arrow as an labeled edges. The reason is, we used to actually pass some labels from one state to another state. Actually we are sending some labels from one state to another state, so we used to call it as an labels. The important condition here is what? While transferring the label from one state to another state, the same label, it have to pass from one state to another state only once, not more than once. That's going to be the rule. But whereas in the NFA, the same label from one state to another state, it will be passing more than once. So in the previous NFA diagram, you will have the initial state what, S0, uh, and then you will have state number 1. So you will have state 0 and you will have state 1. From state 0 to state 1, you will have the movement of the label A, the transition of label A. At the same time, from 0 to 0, you will have the same label transition. So from 0 to 0 also you have the same label transition A, and 0 to 1 also you have the same label transition. The same label is what? The label A. So this is going to be actually a problem. So we must not move the same label from a particular state to another state. Okay. Here in DFA, the condition here is what? We are going to move the same label from one state to another state only once. So this is going to be the important rule that we are going to follow here in DFA. So these are the two important rules that we have in DFA. Okay. And then so here we are going to use some transition tables. So after constructing the diagrammatic representation for your DFA, further we used to construct some what? Transition table. So in transition table you have some columns and you will have some field names. Okay, you will have a column value and then you will have some field names. So in those field names, the first field name which is going to be about the state, and the next columns whatever that we have, all those columns which used to mention the labels whatever that we used to pass in that particular diagrammatic representation. So you have any number of columns, depends upon the label that you're going to use in your diagrammatic representation. So in the table, the first column which denotes the state numbers, and then the next columns which denotes whatever the labels that you're going to use. Okay, and then we used to check that particular transition table in a way that from particular state whether a label is moving or not. Suppose from a particular state, suppose if a label is going to move, and then down to that label name we used to denote what is the receiving state number that we have. So from which state that particular label is moving, and from what is the receiving state that used to receive that particular label. So that will be mentioned in the transition table under each and every columns. So down to each and every label names you will have the corresponding state numbers. Okay. So in NFA you have those representations, like you will have some curly braces, opening curly braces, and then we used to represent some numbers using comma, and then you have closing braces. So such representation, such representations will not be here in DFA. See, in DFA we won't have such representation because we are going to move the same label from one state to another state only once. So we are not going to perform that particular what representation, a representation of using some curly braces, and within that using 1 comma 2, whereas in previous table in NFA transition table we used to mention it. So for the state 1 we are going to move A. How you have an opening braces from 1 to 2 you have, and then from actually 0 to 1 you will have, and then from 0 to 0 you will have. So you have an opening braces, and then you have 0, and then you have comma, and then you have 1, and then you have closing braces. So this is the representation that we have used in the previous transition table for the NFA diagrammatic representation. But here in DFA transition tables we won't have such occurrence of curly braces and more than one receiving state. So in DFA the conclusion is just we are going to have only one receiving state. Okay, for a particular label you're going to have only one receiving state. And that's the first thing. And then we are not going to use curly braces here to represent the sets of states numbers. And the next one, to differentiate NFA and DFA, as we discussed in the previous class, NFA, which is going to be an abstract representation of an algorithm to recognize the input string. So this is going to be an abstract representation. Okay, so you have a whole or overview or overall representation of that particular algorithm for a particular input string. Whereas DFA we used to call it as an simple and concrete algorithm, which is going to be an exact algorithm that we are going to use in DFA, because we are going to ignore the empty string transition, and also we are going to pass a label only once from one state to another state. So you have a concrete algorithm over here. Okay, roll number 21, Pravina. Okay, present. Okay, I have marked attendance for Pravina. So that's the thing. So you have some concrete algorithm for DFA for recognizing strings. And then the next thing, um, um, so it will be in this particular form, it will be in this particular sequence. So first we used to have the regular expression, and for that particular regular expression first we used to construct NFA, and from NFA further we used to move to the construction of the DFA. So this is how we have the sequence. And then here we used to use the L of A, the language named as L of A. L stands for language, and then A stands for actually the alphabet that whatever that we're going to use. So L of A, make a note of these things. So L, capital L, and in bracket you will have what, capital A. So in the previous presentation we have this actually L, which represents what, language, or language in the sense whatever the program or source code or programming language whatever that you're going to use. And alphabet, capital A, which represents actually alphabet. The alphabet which represents what is the input string that we're going to pass, or how many number of labels or group of labels that we're going to pass. So that will be represented using LFA. So for a particular language we are going to construct what, and DFA. So see here we have a particular language. To the same language we are going to construct NFA and also DFA. Okay, so for the same language we would be able to construct NFA and also DFA. So we have two options over here for constructing, and then further the DFA will be simulated to one program, and that particular program will be acting like SWAT, which is going to act like a lexical analyzer for us. Okay, so this is going to be the entire history of DFA, or the entire flow of DFA. Okay, move to next slide, ma'am, please. Move to next slide, please. Okay, so this is going to be actually NFA diagram. So NFA, which is going to accept some regular expression. So the regular expression that we have over here is A asterisk or BB asterisk. Okay, so the asterisk representation which denotes more than one repetition. So the first A in the concentrate or focus on this particular regular expression. So in this regular expression you have what, A asterisk, or the vertical line which indicates R, B asterisk. The first A we don't have any asterisk, but for the second A you have asterisk. But instead of such representations, basically we are going to have what, we are going to have A towards and another A. So instead of representing A asterisk or B asterisk, I think it would be enough to mention what A asterisk or B asterisk, because somehow what you're going to have, you have repetitions of A. So and then why we need to mention that single A or single B. So instead of mentioning like this, it is enough to use what A asterisk or B asterisk, because somehow the A asterisk what is going to represent, which is going to represent more than one occurrence of what A, and B asterisk which represent more than one occurrence of B. And then why we have to have an single A to the left of A asterisk and then single B to the left of B asterisk. But for understanding purposes, they have used this particular regular expression. So here for this regular expression we are constructing NFA. See here in this NFA we have used the empty string representation. From 0 to 1 we have an empty string representation that belongs to symbol, and from 0 to 3 you have that empty string representation that belongs to symbol. Okay, like an epsilon or like summation symbol, you have that particular symbol from 0 to 1 and 0 to 3. So from 0 to 1 and 0 to 3 we are not going to move any label at all, just which is going to be an empty string representation. So basically we are going to ignore that particular empty string or ignore that particular transition. So we are going to start with 0, which is going to be in start state or initial state, and from there first we are going to move to 1 and then we are going to move to 3, and from state 1 to 2 we are moving in single A, just we are going to move a single A. So the first A, now we got the first A, and from 2 to 2 itself you have a transition from 2 to itself. Okay, so what we are moving, the label that we're going to move over here is what A. Okay, so that's going to be like an repetitive or looping process over there actually. So from 2 to 2 you will have any number of A, depends upon how many times that you're going to use that particular loop. Suppose we are going to use that particular loop only once, you will get a single A. Suppose you're going to use the loop more than once, suppose you're going to use it twice, you will get 2A. Suppose you're going to use it thrice, you're going to get 3A. So depends upon how many number of occurrence of that particular loop, you will get that appropriate label A. So you will have A asterisk, and similarly from 3 to 4 you have a single B, and 4 to 4 you will have more than one occurrence of B. So this is going to be a simple representation where the state 2 and 3, which is going to be the accepting state. So here we have two important things. We have used the empty string representation. So basically that must be ignored, but we have used. So that's going to be because from and start state, basically we have to separate into some two branches actually. So for that purposes actually we have used that empty string representation. So from start state further we have to construct one more state, and then where we could pass only a single label, and then from start state to another state, suppose you're going to construct a state, and then suppose if you are going to pass in label, it seems to be a complex one. So instead how they have used it, first you have an empty string representation, and then further you have those uh, A asterisk and then B asterisk. So here we have used what the empty string, the first one, and second thing is we have more than one accepting states. So these are the two important points that we have in this NFA accepting state for A asterisk and B asterisk. So make a note, we have two important points over here. The first important point, we have used the empty string representation. The second important point is we have more than one accepting state. We have more than one accepting state in this NFA representation. Okay. Um, okay. So this is going to be the algorithm that we have over here. This particular algorithm we used to call it as an simulating a DFA. So this is going to be the important algorithm that we have over here. Um, uh, Suppose dear students, if there is going to be any latecomers, kindly let me know at the end of the session. Okay, so kindly give attendance at the end of the session. So Saktivel and then one more is present. Okay, so I have make note of those things, but kindly at the end of the session kindly give attendance. Okay, those latecomers alone, not everyone, those latecomers alone, kindly tell your name and roll number and uh, give me attendance at the end of the session. Okay, so okay, now the algorithm which is going to be simulating a DFA. So this is going to be an algorithm. So simulating a DFA in the sense, using this particular DFA, we are going to simulate it and then we are going to construct somewhat a program. The purpose of simulation is, from DFA we have to construct what? We have to construct some program. So that's going to be the purpose of this particular simulation. Okay, so simulation of DFA. So for this we have an algorithm. So this is very simple algorithm, nothing more complex here in this algorithm. So in this algorithm, the input which is going to be what? You have an input string X. So X, which represents a set of alphabets, which is not a single alphabet here. String, which represents what? Which is going to be some group of alphabet. So for some simplification purpose, simply they are calling it as what? The input string, which is going to be X, small x. But the X, which consists of some group of A or group of B or group of C. So we'll have some set of alphabets over there. Okay, that's about input string, which is going to be terminated by an end of file character. So so here, so whatever may be the process, here the process which is going to be in finite automaton in the sense, you will have some a specific number of steps. With those steps we are going to stop that particular detection of that input string. Okay, so we are going to recognize some input string and then it has a finite number of steps. That's why we are calling it as a finite automaton. So here, to denote the end of the file, so you will have some certain strings, and after recognizing the strings we have to stop working of that particular finite automaton. Okay, so here we are going to use what? We are going to use the end of file character to denote the end of processing. So here in NFA or DFA, what we used to have the accepting states. The accepting state, which is going to be the end of file actually. So after the accepting state, we are not going to process anything after that. So that particular accepting state, which is going to act like what? End of file for us. So here you have a character to represent the end of file, which is going to be EOF. The EOF, which represents end of file. Make a note. EOF, which represents end of file. Okay, and then to denote the DFA, we are using the capital letter D. The DFA, which is represented here using the capital letter D, and then the start state, which has been represented with S0. S0, which stands for initial state, or else we used to call it as in start state. And then accepting state, the final state, which has been represented with capital F. The final state, or what accepting state, we used to represent it with capital F. And then you have a transition function. The function name is move. So these are the various representations that we are going to use in algorithm. So the representations are, the first one, which is about input string X. That's the first one. Second one, end of file, EOF, end of file character, EOF. And third one, DFA, D. And fourth one, start state, or S0, or else we used to call it as initial state. Fifth one, accepting state or final state, we used to represent it with capital F. And then the last one, sixth one, which is about move function. So make a note how many number of inputs that we're going to give to this algorithm. So we have 6 inputs, and then keep in mind that whatever may be the algorithm, we have 3 things. So in compiler design, we used to learn some various algorithm. So whatever may be the algorithm that you people are going to learn, we have 3 subtitles over there. So the 3 subtitles are input, okay, and then methods, and then output. So make a note. I will ask this question at the end of the session. So we have what? We have 3 things for whatever may be the algorithm that you're going to use in compiler design subjects in this particular subject. So in all those algorithms, you will have 3 things, 3 subtitles. The first one, which is going to be input, and second one, which is going to be method, and the third one which is going to be output. That's it. So you have input output, in between you have what method. So the purpose here is you have an input. So in the input, how many representation I have told you? Just we have some 6 representations, like input string X, and then end of file character EOF, and then DFAD, and then to denote initial state or start state we have S0, and then to represent the final state or accepting state we have F, and then to the last we have move function. The total of we have 6 input representations, and using this input we are going to take this input and we are going to pass it to what a method, this particular method which is going to process those input. So using some functions, this input will be get processed by the methods. So methods means what? Normally a function. So in C and C++ language, we used to call it as in what functions, but in Java, the same functions will be called as what methods. So methods are nothing but which is going to be work like, or which used to simulate like a function. So it used to do some actions over there. So this particular method, it used to receive all those input. So here in this algorithm, we have some 6 inputs. So it is going to receive all those 6 inputs, and it is going to do some action over there. And finally, after performing some action, it used to produce output. Okay, so we'll have some output over here. So you have an input, and then the method which is going to do something, and then finally we are going to get what? We are going to get output. So these are the things that we have in this algorithm. So what is the output that we are going to get over here? We have two things, two possibilities actually. We have two possibilities in this algorithm output. The first possibility is yes. So it is going to give the answer as yes. Okay. So if the DFA, if D, capital D accepts X, so capital D which represents what? DFA, and small x which represents what? Which is going to be the input string. So the DFA, which is suppose if it's going to accept that particular input string, so it will give the results as what? Yes. Suppose if the DFA wouldn't able to accept that input string, it is going to give the results as what? Results as no. So simply it's going to give two possibilities of answers. The first possibility is yes, and second possibility is no. So these are the two possibilities. So actually we have learned it in recognizers. So recognizers in the sense which you used to recognize something and it used to give some two results either as yes or no. Similarly here recognizer is nothing but the DFA which is going to be in recognizer for us. This particular DFA which is going to recognize the input string, and then suppose if it were able to recognize the input string, it would give the results as yes. Suppose if it wouldn't able to recognize the input string, it is going to give the results as what? No. So it's very simple. So now you people know about input and output. The major part is what? The method. So what is the method about? So we have some simple method over here. So we have some in this method. We are going to use a function named as move function, and then we are going to use this particular move function. We are passing them two arguments. So the arguments are what? S comma C. S which represents states, and then C which represents one of the alphabet in input string, and not all the characters in the input string, which the C which represents one of the alphabet in input string. So make a note, the second argument of move function, the small c, which represents what? Which represents one of the alphabet of input string. Okay, make a note of these things. Okay, so this particular function, what used to perform? It used to move that particular label. So actually that particular alphabet, C alphabet, which represents a particular alphabet or label, which used to move from one state to another state. Okay, we have some function like what? Move. And then the next function which is going to be next char. So we have another function. The another function here is what? Next char, next char. So this particular function is for detecting the subsequent character whatever that we have in the keywords. So here we are considering what? The lexical analyzer which is going to recognize keywords. So this NFE and DFA actually which is going to recognize what? Keywords. So in keywords sometimes you will have sometimes for most of the times you will have what? More than one character. Suppose you're going to take a simple keyword like if, you have two characters over there. Suppose you're going to take another keyword like switch or case or break or for or do or while. These are all what? Keywords of that particular programming language or any programming language that you're going to use. So in these keywords, for example, first I'm going to take for, which is going to be keyword. Now this particular DFA which is going to recognize that particular keyword. So the first character is going to be what? F. So the first label that we're going to pass here is F, and then the next subsequent label that we're going to pass here is O, and then the next subsequent label that we're going to pass here is R. So we have three labels over here. Okay, we have three input alphabet over here. The first one is F, and another one is O, and another one is R. Okay, so soon after reading the first alphabet, we have to read the subsequent alphabet. To read the subsequent alphabet, we are using the function. The function name is what? Nextchar. Okay, so this nextchar function which is used to read the subsequent character in your input alphabet. So that's about this nextchar function. So which is going to return what? The next character of your input string. Okay, so that's it. So we have some transition graph for this expression. So for the same expression, so we have learned this regular expression using NFA, and for this regular expression we have constructed NFA, and also we have constructed what? We have constructed transition table. um, so here for the same language, okay, this regular expression which is been represented as language here. So for the same language regular expression, so the regular expression here is ARB to the power of asterisk ABB, the same regular expression that we are going to use here. And then here the input string we are going to get here is ABABB. So make a note. So here for example we are going to use only one input string, what? ABABB. Though we would be able to construct more than any number of strings, more than one or two or three or four, you could have more than one input strings. So you will have uncountable input strings could be recognized by this DFA. Okay, so here but we are considering this particular example, what? ABABB as an input string, and then make a note of the state numbers. What are the state numbers that we have? 0 comma 1, and then you have 2, and then you have 1, and then you have 2, and then 3. So from 0 to 1 you have movement, and 1 to 2 you have a movement, and then 2 to 1 you have a movement, and then 1 to 2 again you have a movement, and from 2 to 3 you have movement. So from 0 to 1 you have the movement, and then it used to produce the label A, and then from 1 to 2 you have movement, and then it used to produce the label B, and then from 2 to 1 you have the transition. So movement in the sense transition. Okay, from 2 to 1 you have the transition, it used to produce A. Again from 1 to 2 you have transition, it used to produce B, and then from 2 to 3 you have transition, it used to produce, again it used to produce B. So this is going to be actually the process or the examples that we're going to discuss in this algorithm. Move to next slide please. Okay, so this is very simple algorithm. The first two lines which is going to be about initialization. Okay, and then you have some, what? You have a loop. Within this loop you have two statements, and then you have two more statements at the bottom. This is a very simple algorithm or simple statement which explains the process of DFA. And then the next important thing, the diagram whatever that we have at the bottom, the figure for simulating a DFA, this is very important diagram. So first I would like to explain about this particular algorithm. First, the first two lines, s equal to s0. S0 means what? Which is going to mean start state. So s equal to s0, which denotes first we are going to start from the initial state. That's about s equal to s0, which is going to be about initialization of the start state. And next one is about what? C equal to next character. So we are going to use nextchar function in this algorithm, and then what it's going to actually detect, this particular nextchar function will detect the next upcoming or next subsequent alphabet whatever that we have. So the alphabet which has been represented with some small c. So c equal to nextchar, the c which represents the alphabet, and nextchar which is a function to recognize the subsequent alphabet whatever that we have in your input string. Okay, and then we have a loop. The purpose of loop here is while loop. We are using while loop here. The purpose of while loop is, so first we are I'm going to take a keyword, what? Switch. Okay, so first I'm reading the first alphabet S. From the input string here is what? Switch, and from this input string I'm going to read the first alphabet. The alphabet is capital S, and then the subsequent alphabet is what? W, and next to W you have I, and similarly you have T, C, H, you have subsequent alphabet. So the looping process is soon after reading the first character, we have to read the next character and subsequent character till the end of the file. So the condition here is what? Till the end of the file, we have to read all the characters in the input string. So for that purposes, we are using this loop. The loop is what? While loop. So this particular while loop, which used to read the input string and the characters in the input string till the end of the input string. Okay. So in the while loop, what is the condition that we have set? We have an opening bracket and closing bracket, c not equal to uof which represents what? Uof which represents the end of file. So till the end of that particular input string, we have to recognize each and every alphabet. So you have an opening braces and closing braces. Within this, you have two statements. The two statements are s equal to move s comma c, and then the next statement is c equal to next char function. So the first statement, s equal to move s comma c, which represents the transition from one state to another state, and what we are passing? We are passing the alphabet. Okay, and so that will be stored in s. For example, so you have these things. What you have? S equal to move s comma c, the move function which represents the transition between one state to another state, and then c which represents whatever the alphabet that we are going to detect over there using that particular transition. Okay, so that will be stored in that particular s. And so what is whatever the first character that we are going to detect, that will be stored in that particular small s. Okay, and then the next one, the using next char function, we are going to read subsequent character. So first we are going to read s, and then we are going to read w, and then I, and then t, and similarly ch. So like that we are going to read. So using while loop, we are going to read the entire input string. See the last two statements, what is what it denotes. So if s is in f, so suppose the input string is present in that particular final state after reaching the f, which denotes what? F which denotes the final state actually. So as per this algorithm, as per the input, the f which denotes what? The accepting state or final state. Suppose if we have input string at the end of the final state, and which is going to return what? Which is going to return yes. Suppose if we don't have that particular input string at the end of the accepting state, it is going to produce the result what? Produce the result as no. So that's about this particular algorithm, and then I need some more time for discussion of this particular diagram. So already it's time up. We have just 3 minutes more to go. Um, so so I would like to stop this session with this, and then I'm going to ask a few questions to you. So kindly answer to these questions using chat box. So exactly by 10 we could stop this session. Okay, so I will explain about this particular diagram in the next class. Okay, so from next session will be starting from this particular slide. Okay, so before ending the session, I would like to ask some few questions, just few questions. The few questions are: the first one, the first question, students kindly listen, this is going to be the first question. um, we have two important rules that to be followed in DFA. Okay, and then actually that's going to be the difference between NFA and DFA. We have just two important differences. What is the first difference? So post me any one differences that we have between NFA or DFA. Actually, that's going to be the disadvantages NFA, and in DFA we won't use it actually. Okay, so we have two differences actually. So post any one of the differences in the chat box. Okay, any one of the differences in the chat box. So the first one, who answered first one? First, Vinusri have answered it. No moves on input empty string. Very good, very good. And Deepika, there are no moves for empty string. Okay, good. The same thing. And Shruti, only one label should be moved from one state to another state only once. Very good. So three of you have answered it very correctly. So these are the, and then Nishant have answered no move on strings. Okay. So these are the answers that actually that we have related to this particular first question. Okay, so thank you for answering. Appreciation to Venus, Deepika, and Shruti and Nishant. Okay, the next question is going to be the next question is um, Okay. Um, we have discussed about what simulating a DFA. We have discussed this algorithm. So how many number of input representations? Just you're going to give the numbers alone. How many number of input representations that we have in this algorithm? So most of you are answering very good, very good. So most of you have answered it very correctly. So who is the first one who have answered? Shruti 6, and then Deepika, and then Pradesh, Sindhu, Pravina, Darshana, Cyril, Deepak, Jyotikumar, Nirmal, Soundarya, then Nishant, Meghanathan, Kuklavani, Nijantan. So most of you have answered it very correctly, and then Hari have answered it very correctly. So most of you have answered it very correctly. The answer is what? 6. So we have 6 input representation. The last question for this session, the last question. What is the function name that we use to read the subsequent character of the input string in this algorithm? So what is the function that we use to read the subsequent character in this algorithm? So most of you are answering very good, very good. So what is that? So next cap. So very good, very good. So most of you have answered. So this is going to be the first one is Shruti have answered, and then Sindhu second one, and third one Jyoti, and then Induja, and then Minusri, and then Pratish, Rohit, Nishant, Pravina, Cyril, Gokilavani, Nirmal Vincent, Meghanathan and Deepak. So most of you have answered it very correctly. So thank you for answering. So thank you, students. Thank you for listening patiently and answering. Uh, 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 okay. So thank you, students. Thank you for listening.